Good morning friends, I welcome you all in this session. In previous session we discussed capital budgeting and there are several techniques of capital budgeting. Broadly we can classify them as discounting techniques and non-discounting techniques. So we have seen non-discounting techniques like payback period and ARR, and there are several drawbacks of those two methods. In previous session we have also seen a couple of discounting techniques as well. The first one was discounted payback period. We will quickly go through some of the discounted techniques. So as I said, discounted payback period. So here what we do, we calculate the present value of money which we would be receiving in future, and there would be some discounting factor, and this is the way in which you can calculate discounted payback period, right. We have also seen this example wherein we have been given cash flows over here. This was cash outflow and these are cash inflows, and discounting factor is 10%, right. So we did solve this question in previous session. So in the very initial year, present value factor is 1, right, and in first year it is 1 upon 1 plus 0.10 because discounting factor is 10%. So present value factor for first year is 0.90, right. So you just multiply 30 into 0.90, you will get 27, right. Similarly you can do all other calculations, right. So what we are saying at the end of the day, this is your payback period which is a discounted one, right. So discounted payback period is 4.05 years, right. You can solve this question also. Discounting factor is 10%, and when we solve this question our discounted payback period was 3.21 years, right. So this is again a very simple method. Let us look at profitability index. Profitability index is basically will tell you whether you should select a project or not. You see what happens, profitability index is basically a ratio of present value of cash inflows to present value of cash outflows, right. So if profitability index is 1 or more than 1, it is a profitable project. Net profitability index is profitability index minus 1. Let us look at NPV. NPV is the third discounted capital budgeting technique, right. So in NPV what we do, NPV is the difference between present value of cash inflow and present value of cash outflow, while PI was the ratio of these two, and is the most common used approach. It is very simple and the objective is to maximize wealth of the stakeholders. There are a couple of advantages. It considers all cash flows, even those cash flows which we receive after payback periods, right. It considers time value of money, biggest advantage of this method, but there are certain limitations as well. You need to know a priori the discounting factor. So that is a limitation of this method. So you can solve this question. This is PI, you need to calculate PI NPV, and you are given discounting factor as 10%, right. So should we accept or reject this particular project? Now first of all what you need to do is you need to find out what is present value factor for all these years, right. So this is your 0th year, right, this is 0 here, right. So discounting factor in first year is 0.90, 0.82, 0.75, 0.68 and 0.62, right. So you just add all these values over here in this column, you will get present value as 40.56, right. So this value is positive. As far as profitability index is concerned, is the ratio of what? Is the profitability index is a ratio of cash inflows and cash outflows, right. So, cash inflows is this, right, this total cash inflow, this cash outflow. So, profitability index is 1.25. So, you should accept this project, right. You can also work out this example similar to what we have just seen, right. So, for this question profitability index is 1.189 and NPV is 26.51. So, should we accept this project? Yes or no? Yeah, we should accept this project, right. Let us look at another method of capital budgeting, which is a discounted type, right. IRR, internal rate of return. So, IRR is defined as the discounting rate at which NPV is 0. So, we have to increase or decrease discounting rate in such a way that we get NPV equal to 0, and that would be IRR. A simple criterion can be stated to accept a project if its rate of return exceeds the cost of capital. So, if cost of capital is more than IRR, then you should not reject that project, otherwise it should be accepted, right. So, as it is written very clearly here, rejected if this IRR is less than cost of capital, right. IRR may result in number of complexities. Actually, the problem with IRR is that it does not include size of the project. For a small project also you will be finding some IRR, and for large project also you will be finding some IRR. So, you cannot compare those two IRRs. And the other problem is we assume that the cash flows are reinvested at constant rate, but it is not the case in real life. You can invest cash at different rates, right, it is not constant, right. So, this is the relationship between discounting rate and NPV. So, just look at this graph. Here on y axis you have got NPV and on x axis you have got discounting factor. So, when you increase discounting factor from 5 to 10, your NPV comes down, right, and you need to increase discounting factor until that point when you reach NPV equal to 0, right. So, that is the relationship between these two, and this relationship is not linear, right. But for the calculation of IRR, you can take a small segment of this particular non-linear curve, and that small segment would be a linear one, right. So, what is the relationship between these two? As we increase discounting factor, NPV approaches towards 0, right. So, let us look at this slide which deals with how to calculate IRR. Calculation of IRR is quite a tedious process. It should be done with the help of trial and error method. As we have seen in previous slide also, that when we continuously increase R, NPV decreases. So, you need to increase R such that NPV reaches its 0 value, and that is your IRR. So, let us calculate IRR. So, you have got value of R where NPV is positive and value of R where NPV is negative. So, once you have got these two values, you need to do something called interpolation between these two consecutive values of R, and this is the formula for interpolation. So, IRR is equal to R0 NPV 0 divided by NPV 1 minus NPV 0. Let us look at what these terms are in this particular equation. So, R0 is the rate at which NPV is just positive, right. NPV 0 is just positive NPV, the value of NPV is just positive, right. NPV 1 is that value where NPV is just negative, right. So, you will have NPV just positive and NPV just negative. If you have got these two, we will calculate IRR. So, let us look at this example. In this example, we have to calculate IRR. The duration of the project is 5 years and you have been given cash flows like this. So, let us try this question for IRR. First take discounting rate as 18% and then 17%, and then we will try to interpolate the value of IRR. So, let me solve this question. So, the duration of the project is 5 years. So, here you have got year column. So, this is 0, 1, 2, 3, 4 and 5, and you have also been given cash flows, right. So, initially it is minus 160 cash outflow, right. Then you have got first year 30, second year 40, third year 50, fourth year 60 and fifth year 100, right. Now, let us calculate the present value factor for all these years by taking discounting factor as 18% first. So, the present value factor for 0th year would be 1. For first year it would be 1 by 1 plus, okay, let me directly write it like this, 1 upon 1.18. Second year what it would be, 1 upon 1.18 square. Third year 1 upon 1.18 cube, 1 upon 1.18 to the power 4, 1 upon 1.18 to the power 5. So, this would be, this is present value factor, right, PVF. So, for first year it is 1, for 0th year it is 1, for first year it is 0.847, for second year it is 0.718, for third year it is 0.609, fourth year it is 0.516, 0.516 and finally it is 0.437. If you look at this particular trend, this is continuously decreasing, right. Now, let us calculate what is present value. Multiply these two columns, right. So, here it would be minus 160, right. So, initially it is 1 into minus 160. So, this is minus 160, 30 into 0.847, this is 25.42, then 40 into 0.718, this is 28.73, then you have got 30.43, then 30.95 and 43.71. So, if you look at the sum of all these and when you add this term, you will get present value as minus 0.76. This is minus 0.76. This is the present value with discounting factor at 18%. Now, you need to do this similar calculation for 17% also. So how would you do that? So for 17%, let me extend this table. So first of all, present value factor, right? So initially 1, just like this, 1, 1, then 1 upon 1.17 for first year, 1 upon 1.17 square for second year, 1 upon 1.17 cube for third year, 1 upon 1.17 to the power 4 for fourth year, and finally 1 upon 1.17 to the power 5. So now you can calculate these values, and initially it is 1, right? 1 upon 1.17 is 0.855, then 0.731, 0.624, then you got 0.534, 0.45 and 6. So these are what? Present value factors. Now calculate present value for 17%. So initially you have got 160 minus 160 into 1. So this is minus 160, right, for 0th year. Then 30 into 0.855. So this is 25.64. Then 40 into 0.731. It is 29.22. Then 31.22, 32.02, and finally 45.61. So this is for 0th year, 1st, 2nd, 3rd, 4th and 5th. If you add all these positive values and subtract it from here, or if you take the summation of this particular column, then you will have value as equal to 3.71. So at 17% NPV value is just positive, at 18% NPV value is just negative. Now we know the formula for interpolation, right? And what's the formula? This is the formula. So we'll keep we will put all these values in this particular formula and we'll get IRR. So let us look at IRR. IRR is equal to, we know the formula, it is R0 plus NPV 0 divided by NPV 1 minus NPV 0, right? So this you can write like this. This is 17 plus 3.71 divided by 3.71 minus 0.76. This is equal to 17.83%. So as far as this particular question is concerned, the internal rate of return is 17.83%. Let us look at this question. Let's take discounting rate as 8%, right? Discount rate is 8%. When we solve this question, our NPV is 4,19,500. So this is your initial cash outflow, and this is present value, discounting this rate is 8%. So, this is your discounting present value factor, discounted present value factor for this, and multiply this column with this particular column and add all these values, right. So, you will get NPV is equal to positive, right. So, can we say that this is IRR of the project? No, because NPV is not 0, right. Had it been 0, we would have said this is IRR, right. So, if we change, if we replace 8% by, let us say, by 25%, then NPV will become 0, and that would be your IRR. So, let us check whether this statement is correct or not. Okay. Then the statement is the statement that IRR is discounting rate at which NPV of a project becomes 0. So, we will check whether this statement is correct or not. So, what we should do, let's replace this value by 25%. What will happen? It is 1.1 plus 1.25, right. 1.25, 1.25, 1.25, 1.25. So, square cube to the power 4 to the power 5. Get all these present value factors, multiply present value factors with cash flows and find out whether this value is 0 or not, and this is what is the solution, right. So, this is minus value and all these are plus values, right, and when you add all these, NPV becomes 0. So, it means the statement, so we will say that the statement that IRR is that point where NPV becomes 0, right. Now, we have seen several techniques, right, several discounting and several non-discounting techniques, but how to select the best? In fact, there is no best method or there is no single method, but there are some methods which perform better than other methods, right. So, if you compare these two, NPV and IRR, then if you rank them, then we can say that NPV tops the list, and there are certain reasons for that also. And there are some in fact, this is also true that if you keep all other things equal, then IRR and NPV might give same findings, right, but you can do some more research and can find out which is the best, right. So, over a period of time, firms are using more of discounting techniques rather than non-discounting techniques, and IRR is one of the most popular methods of evaluation, and firms typically use multiple evaluation methods. They do not go for just one particular method. So, there are some screening level methods, then you can do some secondary level of screening, isn't it, or the second level of screening. So, at the end of the day, you need to have a mix of these methods. So, ARR and payback period were widely employed as supplementary evaluation methods. So, why NPV is better than IRR? When we compare NPV and IRR, NPV is better because of a couple of reasons. The first reason is that the IRR presumes that the same rate of return is available in other projects as well. So, if there are several projects, then IRR would assume that the rate of return is same, and if cash flows are not normal, then IRR may lead multiple solutions, right. So, these are two reasons why IRR is not preferred over NPV. Let us look at the assessment of basic evaluation methods. So, you can compare these methods on several theoretical and practical criteria, right. So, if you look at theoretical consideration, and we have taken 4 methods here. So, does the method consider all cash flows? Yes, this method considers all cash flows, IRR also, but payback period it does not consider, right. Does the method discount cash flows at the opportunity cost of fund? NPV does, no other methods do that, right. Does the method satisfy the principle of value additivity? Yes, NPV does that, and this is most important. Are you maximizing wealth of stakeholders or shareholders? This method does that, NPV does that, right. So, if you look at all these 4 criteria, NPV is positive in all these, right, while IRR is positive only on this particular criterion, right. So, these are couple of theoretical considerations, right. Let us look at some practical considerations. Is this method simple? Yes, this is simple. IRR is also simple. Payback period most simple, right. Can the method be used with limited information? NPV you cannot, IRR you cannot, perhaps you can use payback period, and ARR definitely you can use, right. Does the method give relative measure? Only IRR and accounting rate of return, these two methods give relative measure, right. So, if you look at all these 7 criteria, 4 these and 3 these, right. So, total 7 criteria. On 7 criteria, NPV has got yes in 5 criteria, right. So, we will say NPV is the best amongst these, right. So, you can solve this question, and in fact you can do a survey also, and the survey is like this. You can visit several firms and you can ask them which kind of capital budgeting techniques they are using. So, you can give them list of all those techniques which we have just covered in this session as well as in previous session. So, you just give them a list of these methods and ask them which is most widely being used, right. So, let them rank from 1 to 10 or 1 to 5, whatever means how many number of methods you are giving, you let them rank, right. So, I think we have seen total how many, 2 plus 4 I think. So, total 6 or 7 methods we have seen is there in this slide. So, you can do a survey by taking these 6 methods to different firms and ask them whether which of them is being used most widely, right. So, with this we come to an end of this particular session. Thank you very much.